We are today going to talk about a series of studies that we did during my time at Penn State. This actually are data from 2 of the 3 studies that comprise my dissertation research. At Penn State, the way they worked it was you needed 3 independent publications in order to graduate with your PhD. So what we'll talk about today are 2 of the 3 studies that we conducted. And the focus of our topic is going to be physiological responses of lean and obese children to exercise in the heat. So the first study we're going to talk about is going to look at acclimation-related responses. And again, we'll talk about what that means. Again, exposure to repeated bouts of exercise in the heat. Next, we'll talk about sort of the upper limits of heat stress. So how long someone can exercise before that exercise, if they're in a hot, humid environment, starts to become dangerous. How do we define those limits? And we did a study to do that in children. Next, we'll talk about sort of a summary of the 2 studies and what this may mean for future research. And also just want to mention that there's numerous policy statements that are out there that, say, for example, a youth sport coach could refer to see, sort of how hot is too hot. I'm going to do a soccer tournament in, Florida, Arizona, middle of the summer. If it's too hot out, or if the relative humidity is too high, should I cancel that event? And there's numerous policy statements that address that question. The one that's most often referred to is put out by the American Academy of Pediatrics, and they incorporated findings from these 2 studies in their latest policy. So our first study here, again, going to talk about repeated bouts. Come on in, have a seat. Going to talk about repeated bouts of exercise in the heat. And again, those physiological changes that occur. And in the study, we compared responses in lean and obese children. You see our little cutie pie here. All of the pictures that you'll see in the presentation are, in fact, from the studies that we conducted. And for the faculty in the room, yes, in fact, we did get consents from both the parents and the children so that we could use their picture as part of research presentations. So let's sort of set the stage here. And let's make a distinction first between heat acclimatization and heat acclimation. So heat acclimatization occurs in a natural setting. So say, for example, if you were to go outside during the summer, go for a run or a walk. Or even if you were to sit outside, in a chair, perhaps on your patio, wherever you are, and you're exposed to the summer heat. So if you do that repeatedly over time, different physiological changes will occur in your body to help you adapt to that heat. So we have changes that occur in a natural setting, heat acclimatization, and we're going to contrast that with changes that occur in a laboratory setting, which is heat acclimation. So regardless if it's heat acclimatization or heat acclimation, they result from repeated heat exposures that are sufficient to raise an individual's temperature of their body. We're going to refer to that throughout the presentation as body core temperature, so how warm the body is. Also, going to be sufficient to raise someone's heart rate, and also going to be sufficient to raise what's called mean skin temperature. So if I were to measure the temperature at different locations of the body and take an average, that's what mean skin temperature is. And additionally, repeated heat exposures that are sufficient to stimulate abundant sweating. So what happens? What are these physiological changes that occur? And what happens is the body adapts. The body is a miracle. The body adapts to these repeated heat exposures, whether, again, it's a passive heat stress, just sitting in a chair, or repeated bouts of exercise in the heat. What happens? Repeatedly over time, in response to these stresses, the body will reduce its body temperature, will reduce heart rate, so less of a cardiovascular strain. Also, sweating will become more dilute, and also an individual will start to sweat sooner rather than later. Additionally, you get, as far as the blood flow goes, an expansion of plasma volume. So let's go back for a sec. So when you think of blood, you can make the analogy that blood is kind of like Italian salad dressing. So what do I mean? We all know what Italian salad dressing looks like, right? You have a liquid portion and you have formed stuff, right? So similarly with blood, you have a liquid portion and then you have formed stuff. And then the formed stuff would be, say for example, red blood cells, right? White blood cells, other things, platelets. So the liquid portion is going to be partly plasma volume. One of the changes that occur in response to, again, repeated bouts of exercise in the heat is that that liquid portion increases. That's going to help reduce the cardiovascular strain that someone feels while they're exercising. Additionally, research has shown that someone just waking up in the morning, right, their warmth of their body will be reduced over time in response to, again, repeated bouts of exercise in the heat. So these changes that we just talked about, this heat acclimation that occurs is going to be specific to the duration of exposure, so how long someone exercises for, also to the environmental conditions themselves, so how hot it is and or relative humidity, how wet the environment feels, and additionally going to be specific to how hard the individual is working, so exercise intensity. And studies in adults have shown that an adult can fully heat acclimate in 5 to 10 days, repeated bouts of exercise in the heat, with those sessions lasting 1 to 2 hours each day. Now, while both children and adults can acclimate to exercise in the heat, studies have shown that children acclimate at a slower rate and attain a degree of acclimation that's somewhat lower compared to adults. Believe it or not, at the time we conducted our studies, which was about the mid-2000s, there were only 2 studies that had been published that compared responses of lean versus obese children exercising in the heat. I mean, that alone blew my mind. And those studies, the approach that they took was to assess tolerance time. So what do we mean? The time in a fixed environment, so fixed meaning, a certain temperature, a certain relative humidity combination, in which a child is unable to continue to exercise due to perhaps their body gets too warm. In this study, their cutoff point was 39.4 degrees Celsius, which is about 102 degrees Fahrenheit, to give you an idea. Maybe their heart rate gets too high, right? Perhaps the cardiovascular strain is a little too much. But in those 2 studies, which were conducted in the 70s, one was in boys, one was in girls, even though prior to those heat tolerance trials, they did do 3 exercise acclimation in the heat bouts with the kids, they didn't present that data or they didn't discuss it when they published their results. So that was one of our gaps in the knowledge, right? We didn't know the ability of obese versus lean children to exercise in the heat, nor did we have an idea of their rate of acclimation. So believe it or not, exposure to summer heat will confer some degree of natural acclimatization. So again, whether you're sitting outside on your porch in the summer, maybe you do that for 2 weeks, and or if you go outside, go for a run in the summer, you will see some of these changes. So you'll be partially heat acclimated. And studies have shown that in the summer compared to the winter months, right, either if you're sitting on your porch or going outside, going for a run, that the body core temperature and heart rates are lower, and sweating is more profuse and dilute, again in the summer compared to the winter months. And so, since someone becomes partially heat acclimated, again just by exposure to summer heat, in order for them to attain full heat acclimation, it'll occur more rapidly, as opposed to someone who isn't partially heat acclimated. Additionally, fitness plays a role. Someone who is more fit will become heat acclimated quicker compared to their couch potato, right, or sedentary counterparts. In children, studies have shown that those indigenous to tropical climates show a higher sweat rate and a similar heat tolerance as adults. However, for kiddos that live not in tropical climates, right, so a more temperate climate, we didn't know at the time their degree of natural acclimatization, what that degree was, and or how it possibly could impact subsequent acclimation-related changes. So in essence, that was our purpose. What we were looking to find, and again, we had a group of lean and a group of obese children, and 7 lean, 7 obese children, 9 to 12-year-old boys. First thing we were looking to see is, well, what degree of natural acclimatization have they reached? And again, just by going outside during the summer heat. And then the next question we sought to answer was, well, when we artificially, so in the lab, put them through repeated bouts of exercise in the heat, right, what happens? How does that natural acclimatization, so them being partially heat acclimated, how does that impact then subsequent artificial heat acclimation related changes? And again, we conducted the studies during the warm summer months. So our hypotheses. Any of us taken research yet? So what's a hypothesis?
Pretty much an educated guess.
Exactly. Couldn't have said it better, right? So this is our best guess of what we think we're going to happen even before the study starts. And so our best guess of what we thought was going to happen is that the obese compared to lean subjects, just walking in the door before they even started the intervention, right, those exercise in the heat bouts, that they would be less heat acclimatized compared to lean subjects. Additionally, we thought that it would take the obese subjects longer, that they were acclimate at a slower rate compared to the lean subjects. How do you know? You track the body temperature, so body core temperature, how warm the body is. And again, remember we said one of those hallmarks that you'll see is that repeated bouts of exercise in the heat, body temperature over time will decrease. And also heart rate. So again, repeated bouts of exercise in the heat, heart rate will decrease over time. So here are the characteristics of the subjects that we enrolled in the study. Again, we had 7 lean, 7 obese, similar in age, 9 to 12-year-old boys. They were similar in height. As expected, the obese compared to lean subjects weighed more. They had a greater body surface area, a smaller body surface area to mass ratio, higher percent body fat, and in addition, they were less fit. And they were less fit as indicated by results from what's called a maximal oxygen uptake test. This is a test where we measure the maximal fitness effort of someone. So in essence, you can do it on a treadmill or a bike, and what happens is you increase the exercise intensity in stages until eventually the individual is unable to continue to exercise. So that's what I mean when I say maximal fitness effort. So for our subjects, majority of the lean subjects were prepubertal, whereas majority of the obese subjects were midpubertal. So how did we do our study? All subjects in both groups completed 6 exercise in the heat acclimation bouts on separate days. So they came to the lab 6 separate times and exercised in the heat. And we had no more than 2 days between each session. So subjects exercised at 30% of that maximal fitness effort. So 30% is, in essence, a walk on a treadmill. One of the reasons why we picked that intensity is that we needed something that both the lean and obese kids could do, especially in an intense environment. Why do I say intense? Because when they exercised, they were in a climatic chamber. At Penn State, they have 2 heat chambers, climatic chambers, where you can control the temperature and humidity. So it's a room maybe about 3/4 the size of this, and in the chamber we have treadmills, we have bikes, other fancy sophisticated equipment, and what's neat about it is you can control how hot it is, you can control how wet the environment is, and believe it or not, if you screw up, you can make it rain in there. which isn't good, trust me. Then you'd have to write a check for all that equipment to the university. Not a good thing. So we can control the temperature and humidity. So during these exercise in the heat bouts, temperature was held constant at 38 degrees C. That's 100 degrees Fahrenheit and 50% relative humidity. So yes, my friends, it was hot and it was sticky. So during those exercise bouts, again, 30% of their maximal fitness effort, you can see it alternated between a treadmill and a bike for 3 20-minute bouts interspersed with 5-minute rest periods. They're on the treadmill first, then the bike, back on the treadmill, 5-minute rest in between. Before starting the intervention, we took the subject's blood pressure, measured their body weight, and took a urine sample. 10 minutes into each exercise bout, we measured blood pressure, what's called a rating of perceived exertion, so how hard someone feels that they're working, and also a rating of thermal sensation, so how hot someone feels that the environment is or that they are. During the rest periods, you can see here that we measured their body weight, and depending on how much body weight they lost, we gave them water back to drink to replace all fluid lost as sweat. We wanted to make sure that we kept them hydrated. So we continuously monitored heart rate and body core temperature. How did we do that? We did that for body temperature using technology originally developed by NASA for their astronauts. It's called the Core Temp Monitoring System. So you can see here a little pill. It's about the size of a vitamin pill. The coating becomes slippery when wet. And inside the pill, you can see here, has a whole bunch of different components. Draw your attention to the battery here, and then here is a temperature-sensitive crystal. That crystal is going to vibrate, and the vibration of that crystal is going to be linearly related to temperature. So what you do is, for the subject, the day before they were going to do the exercise in the heat bout, they came to the lab, we gave them the pill, they swallowed it, and on the outside of the package of the pill is going to be a serial number. The next day, when the subject showed up to the lab, and you're going to want to make sure that they swallow it the night before because you want to give it enough time for the pill to make its way out of the stomach and into the intestines. So when they show up to the lab the next day, we've already programmed that serial number into our recorder here. So pill's inside of them, it's recording temperature. We place our recorder next to their midsection, push a button, out pops a temperature. So we have, in essence, a real-time readout of how warm the individual is. Additionally, with this recorder, you're able to monitor heart rate via what's called a polar heart rate monitor. So it's a strap that goes right about here, and it will pick up the electrical activity of the heart and also feed it to this recorder here. So what we were able to do, as you can see on the picture, is affix that recorder to the subject with a belt. And from the picture there, you can also see that there is a cord here that's coming outside of the recorder. That cord ran outside of the heat chamber and into what's called a data acquisition system. And that way, we're sitting in front of a computer and we get on a graph, literally a minute, actually it was every 15 seconds, real-time readout of how warm someone was and what their heart rate was. Pretty cool stuff, huh? Yeah. So, as we said, 10 minutes into each exercise bout, we measured ratings of perceived exertion for those who have never seen what the scale looks like before. You can see it goes from 6 to 20 here, and so in using it with a subject, you ask them how hard do you feel that you're working, and they can either call out the number or point to it on the scale. Whereas we also measured ratings of thermal sensation. You see that goes from 0 to 8, so how cold or hot someone feels. If they told us they were cold and 100-degree temperature, 50% relative humidity, something was up, right? Shouldn't be telling us that. Should be telling us they were hot. All right. So during the screening phase, so this is before we started the intervention, subjects came to the lab and they completed the physical activity subscale of the physical self-description questionnaire. So what this is a scale for the subjects to assess how physically active they perceive themselves to be. So it's self-report. And you can see that responses on this scale rank on a 6-point true-false ranking, with 1 being false, 6 being true. And you can see sort of the middle here, 3 more false than true, 4 more true than false, so on and so forth. You see the questions here, for example, several times a week I exercise or play hard enough to breathe hard to be out of breath. Or another one here, I do physically active things like jogging, dancing, bicycling, aerobics, gym, or swimming at least 3 times a week. Results from this questionnaire showed that overall, the obese compared to lean subjects perceived themselves to be less physically active, as indicated by significantly lower rankings on the following questions. I do lots of sports, dance, gym, or other physical activities. Several times a week, I exercise or play hard enough to breathe hard to be out of breath. I get exercise or do sports activities 3 or 4 times per week that make me breathe hard and last at least 30 minutes. So now what we'll look at are the body core temperature responses. So again, this is how warm the individual was. And we have it represented here at baseline. So this is the warmth of their body just walking in the door. So before they went through the intervention. Next here, we have the body temperature responses at the end of exercise. And then last one here, we have the change in the body temperature per trial. Remember I said that we did 6 sessions, 6 exercise in the heat bouts here. And here you can see lean and obese. So first want to direct your attention to how warm their body was day 1 walking in the door. And as you can see, the obese compared to lean subjects had significantly higher baseline body core temperatures. This would suggest that they were less naturally heat acclimatized compared to lean subjects. So again, that exposure to summer heat. Additionally, by day 6 compared to day 1, significant reductions in baseline body core temperature were evident in both groups. So again, remember, repeated bouts of exercise in the heat. What are those physiological changes that occur? One of them is that you're going to see a drop in body temperature. And it's not just during exercise. Again, it's one of the ways in which the body is able to adapt to this new hot environment. And that reduction in body temperature occurred at a similar rate at baseline. Interestingly, for obese subjects by day 6, they attained a baseline body temperature, look at this, that was similar to lean subjects by day 1. So what does this say? This suggests that obese subjects were 6 acclimation days behind lean subjects, which may suggest that an obese subject would need more exercise in the heat bouts in order to attain a degree of heat acclimation that's similar to a lean subject. Now we're going to look at the warmth of the body at the end of exercise. And so we see that by day 6 compared to day 1, significant reductions in the final exercise body core temperature was evident in both groups. But check this out. For obese subjects, that drop in body temperature occurred at a slower rate compared to lean subjects, which again would suggest that obese subjects acclimate at a slower rate compared to lean subjects. Again, suggesting that an obese subject may need additional exercise in the heat bouts before they attain full heat acclimation. And additionally, the change in body core temperature per trial was significantly lower by day 6 compared to day 1 in lean subjects, but not obese subjects. So now let's take a look at those body core temperature responses via graph. So we see here, let's look at it how you're looking at it. On the left, we have the lean subjects. On the right, we have the obese subjects. At the top, we have day 6 compared to day 1, whereas at the bottom, we have all 6 days of heat acclimation graphed. So you can see for both lean and obese subjects throughout all time, throughout each trial, by day 6 compared to day 1, significant reduction in body core temperature in both groups. And additionally, direct your attention to days 5 and 6 here and here for lean subjects, and here for obese subjects. Both groups attained full heat acclimation as indicated by a similar final body core temperature for days 5 and 6 at the end of exercise, in addition to a leveling off of body core temperature during the last exercise bout, which you can see here and here. So again, that would suggest that they attained full heat acclimation. And now let's take a look at the heart rate responses for both groups. Similar setup for the graphs. We have the day 1 versus day 6 at the top, all days of heat acclimation at the bottom, lean subjects on the left, obese subjects on the right. And as you can see, interestingly, we see a significant reduction by day 6 compared to day 1 in the lean subjects for heart rate, but not the obese subjects. And next, we'll take a look at sweat rate. So the rate at which someone was sweating. And we can represent this variable as either what's called an absolute or a relative measure. So it could be absolute here, relative here, which is going to be relative to the size of the person. So relative to someone's body surface area, as opposed to an absolute measure, which here is in milliliters per hour. So as you can see, the relative but not absolute sweat rate was significantly lower in the obese compared to lean subjects. And then next we'll look at the subjective responses. So ratings of perceived exertion, how hard someone felt that they were working, and ratings of thermal sensation, how hot someone perceived themselves to be. And we can see by day 3, continuing into 4, 5, and 6, obese subjects ranked their ratings of perceived exertion significantly higher compared to lean subjects. For lean subjects, by day 6, minute 35 and 60, significant reductions in RPE were observed, day 6 compared to day 1. And now looking at rankings of thermal sensation for day 3, continuing into 4, 5, and 6 at all time points, we see a significant reduction in thermal sensation by day 3, 4, 5, and 6 compared to day 1 in lean subjects, but not obese subjects. So we just said, right, we showed that obese subjects acclimated at a slower rate compared to lean subjects. So that kind of begs the question, well, what gives, right? Why is that? And we had a couple different possibilities that we thought, we don't 100% know. For the first one here, body surface area to mass ratio, the idea is that someone, so an obese subject, who has a larger size compared to a lean subject with more fat deposits, they're going to have a lower, smaller body surface area to mass ratio. And that's important because someone who has a smaller body surface area to mass ratio is going to lose the heat inside them at a slower rate compared to someone with a larger body surface area to mass ratio. So let's back up a sec. So during exercise, right, we need fuel to energy, right, to feed our body to continue to exercise. So we have foodstuffs, carbs, fats and proteins, right, that we've ingested, that the body is then going to process and change into usable energy. But the punchline is, unfortunately, the body isn't very efficient when changing those foodstuffs into usable energy. And what happens is, in that conversion, 60% of that energy is going to be given off as heat, whereas only 40% is going to be able to be used for energy. So as the body starts to exercise, as there's an increased need for energy, right, you're going to get an increase in body temperature just because of breaking down those foodstuffs. So that's what we mean when we say metabolic heat generated, right? Body temperature is going to rise because we're exercising, because we're breaking down those foodstuffs. Additionally, and here's another possibility, that a obese subject who has more fat, right, more adipose tissue. Adipose tissue has a lower specific heat of stored lipid. So what in the world does that mean? Put that in English. That means that you can store less heat in fat compared to lean tissue before you'll see an increase in body temperature. So it could be this, or a combination of both, right? That could have contributed to this slower degree of heat acclimation in the obese compared to lean subjects. Here's another one, again, from the previous studies that have been conducted. They showed that the degree of heat acclimation that's achieved is directly related to the amount of heat that the body stores. So sort of said differently, how well is the body able to cope with a heat stress during exercise? And previous research would say, well, if the body can store more heat, then you can attain a degree of heat acclimation that's better than if you store less heat. But then there's been other studies that say, well, wait a minute, maybe there's some sort of ceiling effect. So an optimal rate of heat storage, above and below which you'll attain a degree of heat acclimation that's lower. So perhaps that played a role. And then also remember, we showed that the relative sweat rate was lower in obese compared to lean subjects. Perhaps that could have played a role as well. So what did we find, again, for our obese compared to lean subjects during the warm summer months? Just walking in the door, they were less naturally heat acclimatized, right? And they also said that they were less physically active, even though we didn't quantify with our questionnaire, you know, if when they were physically active, where they were. You would postulate, you would think that, well, perhaps they're just not going outside running around, right? Maybe they're inside playing video games or something like that. So perhaps that's a reason why they were less naturally heat acclimatized. And also, right, they acclimated at a slower rate, and they had less of an elevation in sweating. So what, who cares, right? And usually when reading a research study, I've taught research in the past, it's what I always tell my students. You always ask that question before and after reading a research article. So what, who cares, why is this important? And for us, right, results from this study may suggest that obese subjects require additional exercise in the heat bouts before they can attain full heat acclimation. And this becomes pretty important, say for example, again for youth sports, you know, exercise out in the warm summer months for those that are running these programs. Questions on that study? So we'll move on to our second study here. And you can see our next little cutie pie there, sweating it out in the chamber. This study was published in the European Journal of Applied Physiology in 2010. And this study looked at the upper environmental limits of heat stress. So answered the question, how hot is too hot during exercise? Right? A pretty important question to answer. Now, before we get into this, let's talk about a couple concepts. And the first one is going to be that of what's called the prescriptive zone. And the idea here is that over a wide range of climatic conditions, so what do we mean? Temperature, humidity combinations, right, during exercise. Over a wide range, that the increase in body temperature is going to be driven by that conversion of foodstuffs, right? That metabolic heat generated. And it's going to be independent of those ambient conditions that are surrounding that individual. So we're saying that converting foodstuffs to usable energy and that heat that's given off as someone is exercising, that is what's going to drive that increase in body temperature even if someone's outside on a hot day. Okay, so that's what's called the prescriptive zone. But eventually, sometimes, there exists a temperature, humidity combination that in essence is too hot, and it's going to force the individual's responses outside of that prescriptive zone. And that's the point that it starts to get dangerous. That's the point when that increase in body temperature is not going to be from metabolic heat generated, but it's going to be driven by the environmental conditions. And so what we sought to do in this study was to determine that point, determine the point at which it's too hot to continue to exercise. So again, back to those two studies before we conducted our study that looked at tolerance time. So time in a fixed environment in which a child is unable to continue to exercise. Again, conducted in the 70s. One was in lean and obese boys, one was in lean and obese girls. And that study, those two studies showed no difference in tolerance time, but they showed an increase in body core temperature and heart rate during the trials. Now, from those two studies, in addition to only a few others, you can get an idea of how hot is too hot. And from those research studies, different organizations have written position stands to set restraints on activities outside at different temperature humidity combinations. Again, we said the American Academy of Pediatrics is the one that's most often referred to. But the issue was that for those previous studies, say for example, they do a study, so they do one trial at one temperature, one humidity combination, and then maybe they increase the temperature 10 degrees. And then they do the next trial at that temperature, that humidity combination, right? And then they do the same, do the same. So in that situation, you can get an idea of how hot is too hot, but you don't really know that point, right? And isn't knowing that point important? And so that is in essence what we did with our study. And we were hopeful to answer the question, is that point, what the position stands had currently said? Should that point be different for lean and obese children? So should we have separate guidelines? What should it look like? So our hypothesis, right, our best guess of what we thought, and that was that obese subjects would have a lower limit, it's called a critical environmental limit, compared to a lean subject. So how did we do this study? So this study was a continuation of the previous study. And what we did, as you just saw, was first we acclimated the children to exercise in the heat. You need to do that so that the subsequent exercise in this study that they conducted, that they were safe while they were doing that. Their body had already acclimated, had those physiological changes occur. So those same 7 lean and 7 obese boys who are already heat acclimated, what did they do? They came for 4 sessions in which they exercised at different temperatures. So the temperatures range from 34, 36, 38, or 42 degrees Celsius. That's anywhere from 93 degrees Fahrenheit up to 107 degrees Fahrenheit. I was in the chamber. It's hot. You immediately start sweating as soon as you walk in. So that's the temperature, and the temperature was held constant. What about the humidity? And in this study, we used water vapor pressure, somewhat of a similar idea, how wet the environment was. And what we did was, again, remember, we're in an environmental chamber. We can control the temperature and humidity, right? So we keep the temperature constant at one of those 4 different temperatures, depending on the trial. And with the wetness, if you will, the water vapor pressure, after a 30-minute equilibration period at 9 torr, we then increase the wetness of the environment 1 torr every 5 minutes. So what happens is the individual starts exercising, and yeah, it's hot, it's not too wet, but eventually the environment becomes more severe. And eventually it will force the body outside of that prescriptive zone. We continuously monitored body core temperature and heart rate, and also monitored mean skin temperature via the mechanism that we previously mentioned. Additionally, we monitored their blood pressure, ratings of perceived exertion, and also thermal sensation every 10 minutes. So let's look at a typical response from a subject as far as their physiological responses. So here on the graph, we have the water vapor pressure. So that's how wet the environment was. Here we have mean skin temperature, so again an average of the temperature of all the different locations around the body. Here we have body core temperature, and here we have heart rate. So for body core temperature here it's in yellow. For heart rate here it's in white. So let's take a look here at the water vapor pressure. Remember we said we had a half-hour equilibration period, right? And then we started the study. And the environment started to become more wet, if you will. And so, as we talked about, for that prescriptive zone, as the individual starts to exercise, and for this study they walked on a treadmill at 30% of their maximal fitness effort, VO2 max. So again, walking on a treadmill at a nice pace, nice comfortable pace. So the body temperature starts to climb, and this increase in body temperature, again, remember, is driven by converting those foodstuffs, and in that conversion we're giving off heat, and this increase in body temperature is really going to be independent of those conditions that are surrounding the ambient conditions, the temperature and relative humidity combinations that are surrounding that individual. And eventually, since we have a steady state of exercise, meaning we didn't increase the exercise intensity, we reach a new steady state for body temperature. But as we see, eventually there's going to reach a point with the environmental conditions as they become more severe that it's going to force the individual's body core temperature outside of that prescriptive zone. And you see, and I can tell you, because again I watched every graph, it takes off, right? There's no mistake about it. You can see on the graph there, body temperature just goes, right? And if that individual were to continue to exercise, it would become dangerous. And so we did all of those trials, six acclimation in the heat bouts, and these 4 now trials, all of that work just to get one point on a graph. And that is right here. The point at which it becomes too hot for the individual to continue to exercise. Also, take a look at heart rate here. You can see that heart rate, about 10 minutes prior to body core temperature taken off, heart rate starts to rise. So the heart is trying to compensate for this increased strain of the exercise combined with the ambient conditions, environmental conditions becoming more severe. So regardless of how we express this, whether it was via critical water vapor pressure, critical wet bulb globe temperature, critical relative humidity, or critical wet bulb globe temperature, all the same punchline, right? Those limits were lower for obese compared to lean subjects. This is what's called a psychrometric chart. Don't know if you've ever seen one before. On a psychrometric chart, you have the temperature, which is technically called dry bulb temperature. You have the water vapor pressure here, and you have the relative humidity here. So this you can see graphically when we say those limits were lower, what do we mean? The open circles are the obese kids, and the filled in circles are the lean kids. And from this you can see, right? Those limits, that point on the graph, when it starts to become too hot, too dangerous for the individual to continue to exercise, were in fact lower for obese compared to lean subjects. As far as sweat rate in this study was a similar finding from the other study. The relative but not absolute sweat rate was significantly lower in the obese compared to lean subjects. And additionally, for the ratings of perceived exertion and thermal sensation, at in essence, every time point, just about every temperature with the exception of 34 degrees C, minute 10 for thermal sensation, the obese kids felt that they were working harder and that they were hotter compared to the lean subjects. So what we did, right, if someone says to you, water vapor pressure may not be something that you're too familiar with, and we wanted to make this data user-friendly, right? So relative humidity, everyone's heard of relative humidity, right? You can get that off the internet, you can get that on the news, right, with the weather. So what we did was represent this data as temperature and relative humidity combinations, but what we also did was shifted down these relative humidity findings 2 standard deviations below the mean. When you get in stats, you'll find that that means that it should be protective for 95% of the population. So we have now temperature and relative humidity combinations that someone could use for both lean and obese subjects to try and figure out, hey, if I'm running a soccer tournament in the middle of Arizona in the summer or Florida or wherever else, you know, here's the temperature, here's humidity, should I cancel my tournament? And again, we have some data now to answer those questions. And again, we'll put up the factors here, which are the similar factors that we talked about related to the acclimation study as far as why those critical environmental limits may be lower for obese compared to lean subjects. We won't go through them again. And so what did we conclude? Well, in 9 to 12-year-old boys who are already heat acclimated, again, those critical environmental limits are going to be lower for obese compared to lean subjects. And again, the so what, who cares, right? Why is this important? And the answer is, well, our findings which suggest that we need separate guidelines for obese and lean kids, right? You can't take a one-size-fits-all approach because according to the physiology that we found, it doesn't. So as far as future studies, implications of this, this work, right? We had a small sample size and we also had only boys in the study. So, well, what about girls, right? And certainly future studies should address that. There are factors that in a laboratory that you can't 100% replicate as far as something outside. So what do I mean? Say, for example, radiant heat from the sun, right? So, you know, close your eyes and think about a nice warm summer day, which is not what today is, especially with the severe weather that we're having, but close your eyes for a sec, think about a nice warm summer day, right? The sun's out and it's warming you. Feels nice, right? We can't take the sun and put it in the lab. So, unfortunately, that's not something that we can control for, but that warmth of the sun may play a role if someone goes outside and exercises. So with that, I'd like to acknowledge the many people that were part of this series of studies that we conducted, especially, first and foremost, the kiddos that were part of the study. I mean, when you hear something like 107 degrees Fahrenheit and they were exercising for upwards of 2.5 hours per session, it was intense. And again, they were troopers and they did a fantastic job. We also had numerous grants that were funding this study that you can see here. And with that, I'm happy to take any questions that you may have.